Next example on Leibniz theorem. If A is A cos log x plus B sin log x, then prove that x square yn plus 2 plus 2n plus 1 x yn plus 1 plus n square plus 1 yn is equal to 0. So we have to prove this equation. And if you observe this term yn plus 2 means the n plus 2 order derivative. This is n plus 1 order, this is nth order. So the highest order derivative is n plus 2 order. And that's why we have to differentiate this y two times. That is, we have to find y1 and y2, and then we have to apply the Leibniz theorem. So y is a cos log x plus b sin log x. So y1 is a, derivative of cos x is what? Minus sin x. So derivative of cos log x is minus sin log x, right, in bracket, into derivative of log x is 1 by x, plus b sin log x, derivative is cos log x, right, log x in bracket, into derivative of log x is 1 by x. So take x as LCM, into 1 by x means divide by x, and take x as LCM and then shift x to LHS. We have x y1 is equal to minus a sin log x plus b cos log x. Okay, so this is the first step. After first order differentiation, we have this step. So if the steps are what? If there is a quantity at denominator, then shift it to LHS, and if there is a square root, then squaring both sides. And if you have to adjust, if it is possible to adjust y at the first step, then adjust y. But it is not now possible because y is a cos log x and here is a sin log x. So we have to again differentiate with respect to x. So the derivative of x y1 is what? X y2 into the rule x, derivative of y1 is y2 plus y1 x, derivative of x is 1 is equal to minus a constant, derivative of sin log x is cos log x divided by x plus b, and derivative of cos log x is what? Minus sin log x into 1 by x, and then take x as LCM or multiplying by x throughout. What do we have? X square y2 plus x y1 is equal to minus a cos log x minus b sin log x, and then take minus sin common. We have a cos log x plus b sin log x, and its value is y. A cos log x plus b sin log x is y. That is, adjust y, and then shift this y to LHS. We have this equation: x square y2 plus x y1 plus y is equal to 0. That is, we have the after second order derivative, we have this equation. Now we have to find the nth order derivative of this equation. From this equation, we have to find the nth order derivative in order to prove this. So differentiate this equation star n times with respect to x by Leibniz theorem. We have this step. So don't write all these steps. So x square y2, this y2 is u. So this y2 is continuously differentiable function, while x square is not continuously differentiable function. After some step, we have the derivative of x square is equal to 0. What is the derivative of x square? First order derivative of x square is 2x. Then next order is 2. And the third order derivative of x square is 0. Fourth order is 0. So after some step, we have the derivative of x square is 0. Means this function is not continuously differentiable. So this y2 is continuously differentiable, denoted by u, and x square is not continuously differentiable, denoted by v. And then apply the Leibniz theorem to find the nth order derivative of x square y2. So what are the terms? The terms are this. So what is the Leibniz theorem? This is the Leibniz theorem. The first term is nc0 unv, then nc1 un minus 1 v1, nc2 un minus 2 v2. So these are the terms. The value of nc0 is 1, nc1 is value is n, nc2 value is n minus 1 by 2 factorial. In this way, the remaining terms. So the terms of the derivative of this term x square y2 by using Leibniz theorem. So the first term is what? nc0, that is 1. Then un means what? The derivative of y2 with of nth order. So it is yn plus 2. Nth order derivative of y2 is what? N plus 2 order. X square, v as it is, means x square. Plus next term n c1, value is n. Then un minus 1 means the derivative of y2 of n minus 1 order. And it is what? 2 plus n minus 1, that is n plus 1. 2x. What is 2x? v1 is what? 2x, x square, derivative of x square. Plus next term is n c2, value is n minus 1 by 2 factorial, means 2. Then y2 un minus 2 means the derivative of y2 of n minus 2 order. So the derivative of n minus 2 order of y2 is what? 2 plus n minus 2, that is yn. Then v2 means the second order derivative of x square. The first order is 2x, so second order is 2. And then all the remaining terms are 0. What is the next term? Is nc3 un minus 3 v3. And what is v3? v3, that is the derivative of x square of third order, is 0. So the remaining terms are 0. So these first, this is second, and these three terms are the nth order derivative of this term x square y2. These first three terms in this step are the nth order derivative of x square y2. Now we have to find the nth order derivative of x y1. Again, y1 is u, x is v. And now first term is what? 1 nc0, that is 1, and un means derivative of y1 of nth order is yn plus 1 into v as it is x, plus next term is nc1, value is n, then un minus 1 means the derivative of y1 of n minus 1 order. So 1 plus n minus 1 is yn, this term yn. Then v1 means derivative of v with respect to x is 1, derivative of x with respect to v is 1. Okay, and the next term is what? The next term is nc2 un minus 2 v2. And what is v2? v2 is 0. So the remaining terms are 0. So these two terms are the nth order derivative of x y1, plus this y, its derivative is yn. Nth order derivative of y is what? Yn is equal to 0. So this is what? This is the step after this step by applying Leibnitz theorem, and this is the nth order derivative of this step. So next is now adjustment. So this is yn plus 2x square. This is yn plus 1 is 2 x nx, and this is the term x plus x. Take yn plus 1 as common from these two terms, and these two to get cancelled, and then take yn as common from the remaining three terms. So we have n in bracket n minus 1 plus n plus 1. Okay, after taking yn as common. And so after simplification, we have x square yn plus 2 plus take x as common. So we have in bracket 2n plus 1 x yn plus 1. And this after simplification, so right, multiply by n. So n square minus n plus 1. So minus n plus n get cancelled. So n square plus 1, we have the simplification of this bracket into yn is equal to 0. And that is why I have to prove. So next theorem, y is sine inverse x bracket square, then we have to prove this. So y is sine inverse x bracket square. So already this example is described in the previous lecture, but we take again repetition of this example. So y is sine inverse x bracket square. So we have to prove this, and yn plus 2 means the n plus 2 order derivative. So highest derivative is of n plus 2 order. So I have to differentiate this y 2 times. That is, we have to find y1 and y2, and then we have to apply the Leibniz theorem. So y is sine inverse x bracket square. So y1 is 2 sine inverse x by using x raised to n root. 2 sine inverse x into the derivative of sine inverse x is 1 by root 1 minus x square. And then shift this root 1 minus x square to LHS. So we have y1 root 1 minus x square 2 sine inverse x. So this is the first step. That is, if there is a quantity at denominator, then shift to LHS. And if there is a square root, then squaring both sides. We can also find the derivative without squaring. So either square this squaring and then find the second order derivative, or we can directly find the derivative. So y2 root 1 minus x square u into v rule plus the derivative of root 1 minus x square is 1 by 2 times root 1 minus x square into 2x minus 2x. The derivative of root 1 minus x square is what? Minus 2x into y1 as it is. So u into v rule is equal to 2 sine inverse x derivative 1 by root 1 minus x square. And then we have y2 root 1 minus x square plus not plus minus 2x y1 to get cancelled. Root 1 minus x square is equal to 2 divided by root 1 minus x square, then multiplying by root 1 minus x square, and we have this step. So follow the answer of this problem as previous problem. So these are wrong steps. So after shifting this root 1 minus x square to LHS, squaring both sides and then solve the example. Yes, this is the steps. So yes, y1 square is equal to what? Square of this quantity is 4 sine inverse x bracket square. Don't write these three steps. So after this step, write squaring both sides. So y1 square is equal to 4. To square of 2 is 4 sine inverse x bracket square, and root 1 minus x square, its square is 1 minus x square. Then shift this 1 minus x square to LHS. So we have 1 minus x square, y1 square is equal to 4 sine inverse x bracket square, and sine inverse x bracket square is y. So adjust y, and then shift this y to 4y to LHS, and then differentiate again with respect to x. So u into v rule, 1 minus x square, derivative of y1 square is what? 2y1 into y2. Derivative of y1 square. 2y1 into derivative of y1 is y2 plus y1 square, derivative of 1 minus x square is minus 2x minus 4y1, derivative of y is y1 is equal to 0. Then we have this step, and after dividing by 2y1, we have dividing by throughout by 2y1. So we have the step this 1 minus x square y2 minus xy1 minus xy1 minus 2 is equal to 0. So we have this after dividing by 2y1, and then apply the Leibniz theorem. We have this step. So 1 minus x square yn plus 2, the derivative of yn y2 is what? The first step yn plus 2, nth order derivative, plus nc1 value is n, and the derivative of then next term is what? nc2 yn plus 1 minus 2x, yn plus 1 minus 2x, and then next term is what? Now term is what? n minus 1 by 2 factorial, that is 2 yn into 2 into minus 2. Okay, write all that step. We have this final answer. So next example is x tan log y. Then we have to prove this. So x is tan log y. So we have to find the value of y first. So shift the tan to LHS. So we have tan inverse x is equal to log y. That is log y is tan inverse x, and so y is e raised to tan inverse x. Log y is tan inverse x. So y is e raised to tan inverse x, and then because log a is b, then a is log e raised to b. That is exponential function is inverse of logarithmic function. So we have y is equal to e raised to tan inverse x. So y1 now differentiate twice. We have to find the yes. If you observe the this equation, then it is highest order derivative is of n plus 1 order. So we have to differentiate single times, and then we have to apply the Leibniz theorem. So what is the derivative of this quantity? Is y1 e raised to tan inverse x, derivative is e raised to tan inverse x into derivative of tan inverse x is 1 by 1 plus x square. And so we have y1 is e raised to tan inverse divided by 1 plus x square. Shift this 1 plus x square to LHS, we have this, and then adjust y. Y is what? Y is e raised to tan inverse x, that is substitute e raised to tan inverse x as y. So we have this equation 1 plus x square y1 plus y is equal to 0. Then apply Leibniz theorem, because we have to prove this equation. 1 plus x square yn plus 1. So highest order derivative is of order n plus 1, and so differentiate single times and then apply Leibniz theorem. If it is the term, the highest order derivative term is n plus 2 order, then differentiate 2 times and then apply Leibniz theorem. So by Leibniz theorem, the derivative of nth order derivative of this quantity 1 plus x square y1. So y1 is u, 1 plus x square is v. So the first term is nc0, that is 1. y1 its nth order derivative is yn plus 1. 1 plus x square, write 1 plus x square as it is, write in bracket 1 plus x square, that is v as it is, plus next term is nc1 value is n, un minus 1, that is derivative of y1 of n minus 1 order is what? Yn into derivative of a1 plus x square is 2x v1 term, then n minus 1 by 2 factorial, that is nc2. Then un minus 2, that is the derivative of n minus 2 order derivative of y1 is 1 plus n minus 2 is yn minus 1 into derivative of into v2 means the second order derivative is 2 of 1 plus x square is 2, and the remaining terms are 0, plus derivative of y, nth derivative of y is yn, so right here yn, and then collect the terms. So this is right here 1 plus x square, 1 plus x square yn plus 1, and then collect the terms of yn, this right here yn. So simplify, we have the final answer. So we'll see the remaining problem in the next section. That is e raised to y is e raised to m cos inverse x.